LDP configuration. In this video, I'm going to talk about LDP. LDP is the abbreviation of Label Distribution Protocol. And LDP is a protocol that automatically generates and exchanges labels between routers. Each router will locally generate labels for its prefixes and will then advertise the label value to its neighbors. I will mention it in previous videos. First, review the usage of LDP. You know that if we have one network, for example R1, R2, R3, R4, and finally R5, and we enabling MPLS on these routers with one of the two methods, interface config method or IGP config, MPLS, and here MPLS, and again MPLS. Every router for every prefixes that resides in its routing table should generate a label. This is one of the function of LDP. And LDP generates automatically labels for every prefixes in the routing table of routers. This is the first function. And the second function is to advertise the labels between routers. You know that, for example, if we have here a network connected to R5, for example, net A, all of the routers with OSPF as a routing protocol or EIGRP or some other routing protocols should choose a label for net A that is locally generated label. For example, L1, okay? L1 for R1, and again L2 in R2, and again, for example, I can write here net A once, and then L1 R1, L2 R2, L3 generated by LDP in R3, and also L4 and also L5. And you know that every router should exchange its label to the neighbors. For example, R5 should send its label to the R4, R4 should send to the, for example, R5, and also to the R3. And then R3 should send its label to the R4 and again to the R2, and after that R2 should send its label to the R3 and again to the R1, and finally R1 should send its label to the R2. Generation and exchange of labels is the function of LDP. LDP is Label Distribution Protocol. I want to mention that the first protocol that is used in first years of the tag switching network or MPLS is another protocol, is a Cisco proprietary protocol. Its name is TDP. TDP is the traditional or old protocol for distributing and generating and distributing labels. Tag distribution protocol. Tag distribution protocol is the first protocol that is used to generate and advertise labels in a tag switching network. Cisco chose this name for the first MPLS networks. After that, after some years, LDP created, and the LDP, you know that the abbreviation of Label Distribution Protocol, and it's an open standard. Its function is generation and advertising labels in an MPLS networks, label switching network. Okay, now we only use LDP and we don't use TDP in our networks, but the story between LDP and TDP is same as the story between, for example, 802.1q and ISL, or PAGP and LACP. Cisco created a protocol, the name is TDP, or Tag Distribution Protocol, and then a standard was created later. Nowadays, almost everyone uses LDP instead of TDP. Because of that, in all of the MPLS courses, only LDP should be taught, and only LDP is used in the networks today. Okay, very good. We want to talk about LDP. Is the Label Distribution Protocol. LDP uses TCP and UDP port of 646, and TDP uses TCP and UDP port of 711. Okay, I want to talk about LDP basic configuration, and after that we delve into LDP and some specific functions, for example, neighborship and other things. Okay, first we should talk about LDP itself and how we can enable it and how we can configure it, some of the configuration options, and going to the deep dive in the LDP functions. Okay, let's get started with our scenario. I want to use this scenario for configuring LDP and checking some other functions of the LDP, or Label Distribution Protocol. First, we should configure it. Okay, we have configuration of this scenario from R1 to R5. Copy R1 configuration. The configuration is basic IP addressing, configuring host name, and enabling OSPF as a routing protocol, or other routing protocols. You can use other routing protocols. I use OSPF, and in R1 I should copy the configuration. This is the configuration of R1. And second, in R2, copy the R2 configuration, only IP addressing, and then enabling routing protocols. This is the configuration of R2. Then we should go to the R3. This is the configuration of R3 here, and then we should copy and paste it here. Look at here. This is the R3, and again for R4, and after that for R5. Now we can begin the LDP configuration and checking some parameters. The last router is R5. Okay, copy the configuration of R5, for example, from here, and then paste it in the R5 CLI. Okay, we can now start. How we can use LDP and how we can enable LDP. You know the answers before I started this video. Why? Because in the previous videos you enabled LDP, you enabled MPLS, and because of that you enabled LDP. Okay, I want to review the topics I mentioned before in the configuration of MPLS. You can enable MPLS in a router if IPsec is enabled first. Because of that, we should check it with the IPsec command, and you know that this command by default is enabled. Sec by default is enabled, and we don't need to enable it by default. After that, MPLS IP should globally be enabled, and this is by default enabled, also by default enabled. And then we can configure MPLS. The first way to configure MPLS, this is the first way, is we are going to the interface router config if, and using this command MPLS IP, this is the interface config mode or interface config way. And another way to enabling MPLS and also LDP is using the IGP config. You know that we can use this command for example in OSPF router config router OSPF process ID, and then router config router, MPLS, LDP, IGP, MPLS LDP auto config, MPLS LDP